Hi there. I just want to take an opportunity to describe to you what I work on with my students with respect to patterning and algebra. But actually, I don't like to think of it as one strand of math because I believe that all the strands tie together. And you will see that through this model that I do regularly with my students. For example, you're going to see data management with graphing, and it also ties really well with financial literacy and so on. It's important to understand that all math, regardless of what we're doing, is solving something. We're trying to make sense of the numbers. We're trying to solve something. We're trying to see patterns that are happening in it, predict where the numbers are going to go and where they came from, and so on. So that is the root of patterning in algebra and one of the most important things that we can be teaching students. So I introduced this early in the year, and in my classroom, I spiral the math, which means that I revisit this concept regularly through the year, building our understanding. I will first give credit to Tracy Grace, who introduced me to this concept in a Math AQ course that I had taken with her instruction. I have adapted it for use in my classroom and then adapted it again for digital remote learning. So I'm happy to share the template of the file, but describe what I am doing with this file so that it makes sense and you can build upon it properly in your classroom as well. I also introduced this early. I have used this with my students in grade 2 with some of the pattern representations. And through the years, we can build on that. So by grade 4 or 5, we can maybe be working with the graphing, the data management of it. And by grade 8, we can be building the algebraic formula. And we can also be exploring representations, not the formula, but representations of nonlinear patterns so that they are prepared with understanding when they go into high school and work with the formulas on that in there. So this carries through all of the grades. I always begin with the picture pattern. So you can see here I have puppies that I am using for this pattern. And then over time, I will build to numeric representations. So I have a picture pattern in a linear increasing pattern. I will move toward decreasing linear patterns, and then I will build to numeric patterns with word problems that tie really well with financial literacy, for example, such as if I start with $5 in my piggy bank and I make $10 a month in allowance, how much money would I have after 2 years? That would be an example that we can use in this context. For these pictures, I frequently use a website, visualpatterns.org. It has hundreds of patterns in here. You can see up here, hundreds of patterns. Not all of them are linear, so you can certainly draw from this. Just be careful of your selection that it is intending what you want it to do. Better yet, if you are using an in-classroom model, have your students build using concrete materials, the patterns, and then you can use those, what you are making in classroom as primary data, to be entering in for these representations. But for this sake, I'm using the puppies that I found right here. And I have just put the picture in as such, and you can just switch this out as needed. I have the students begin by understanding the vocabulary that I'm going to use so that this can build through the years. So at first I might say this is picture 1, picture 2, picture 3, picture 4, and how many puppies are in each picture. But I want to teach the kids that the math vocabulary is term 1, term 2, term 3, term 4, and that the number of puppies is called the value. So they will begin by entering the value. I have pre-put this in just for time's sake. I have 1 puppy, then 3 puppies, then 5 puppies, then 7 puppies. And we can begin to identify what is happening in the pattern and coming up with our pattern rule. So we are starting at 1 puppy. This is an increasing pattern, and it is increasing by 2 each time. So in early years, kindergarten, grade 1, the kids would be building puppies. You would have concrete materials and you would be building the puppies. And you might say, well, how many puppies would be in the 5th term? And the students would come up with 9 puppies, but they would be building that concretely. Or they might move to starting to draw it out, which is moving their understanding, their development forward. But eventually, that is a lot of building, it is a lot of drawing, and it is inefficient. And so we need to find more efficient ways of predicting how many puppies would be in later terms. So my goal is to show efficiency through this, that we're going to show different models, but eventually these models will become inefficient and we need to move to another model. Eventually that will become inefficient. And as we get into larger values, then it would make sense to use a formula, which is why we come up with the algebraic formula. So that is my goal through this. So I have included some digital tools that I like to use in my class here. This first one would be having the students use a number line. And so they can do it on a piece of paper and insert a photo if you are teaching remotely, or they can use this digital tool, which is great because it's nice and pretty. I have started this for sake of time, but I like to show where we are starting, how much it is increasing by each time, and have the students label up above that this is term 1, term 2, term 3, and term 4. So we had 1 puppy, 3 puppies, 5 puppies, 7 puppies. You can see for this sake, I put in term 0 here, which would have a value of -1. We're going to come back to that. This is something that I want as the understanding for the students in grade 8 for developing the algebraic formula. So in early grades, you do not need this part, but in later grades, this would be good for them to represent to show their understanding of what is happening in the pattern. Now that we have this, we can extend the pattern beyond what has been pictured. We have 4 terms. Let's continue to extend this. So I can click on, what did I do? I can click on this and I can extend it. And if I took the time, I can label each of these and say this is term 5, term 6, term 7, term 8, term 9, term 10, term 11, term 12. While we're here, I'm going to put term 12 up here because I want to come back to this. What did I say? So term 4, 5, 6, 7, 8, 9, 10, 11, 12 right here. So the value at term 12 should be 23. I'm just going to mark that right here. 23. Whoop, my computer just did something funny. That's okay. 23. Okay. We're going to come back to that. I want to show that as an extension as well. But we can see if we were to draw this picture out 12 times that we would have 23 puppies in our picture, in our term. So what I have the students do is I have them print their screen and do a screen capture of this, and then they can drop their understanding into the slides if you are teaching remotely. So I'm going to just paste that here. And then it's a quick and easy way for the students to be able to represent their thinking. But I want to show you, I'm just going to make this good and small so that I have some room to work here. This website, mathlearningcenter.org. Oh my goodness, so fantastic. It has all different kinds of tools. But as well, you can see that there is a share button right here. The kids can even save the image directly here, and then they can paste that into their slides, or they can simply share a link of their work. So they can click on copy link, and they can drop it into their slides as well. And so then, I think I put it over there, but you can see. And so then the teacher can go to that link later and be able to open up their work. So that is a way, if you are teaching digitally, that your students can show their work. But eventually, the number line becomes inefficient. You can see if I were to continue this forever, it would just get to be too long. So we need to see another representation that would be a more efficient way of showing what is happening with the pattern. So let's take a look. On the next slide, I have an interactive 100 chart, and this is very easy to use even in the early grades. Grades 2, they really can use a 100 chart quite well. I like this website, ABCA. Here is a link for it, or the kids can click and drag these dots and represent on here. But to make it digital, I like this ABCA because they can build that in here. So we can see that we had, I'm going to make this orange, 1 puppy in term 1. Then we had 3 puppies, I think. 3, then 5, then 7. 5, 7, 9. And then if we were to continue, it would be increasing by 2 each time. And eventually, as the kids are counting these out, they're going to start seeing a pattern happening on their 100 chart. And every 100 chart is going to look a little bit different. So it makes sure that they know that what is happening with their 100 chart before they start filling it in. But I can see a pattern starting to develop here. I can see that I am making rows or columns, excuse me, in the odd numbers. So I can just quickly fill the rest of those in. And do you see how much more efficient this is than if they were to draw or build it out or even to make that number line? And a 100 chart is just a number line but stacked. When we got to 10, we just took the next batch and we put it underneath. So it's the same thing but just stacked. And now we have a 100 chart right here completed in. If I were to ask now, how many puppies would be in the 12th term? Well, let's count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There would be 23 puppies in the 12th term. Is that what we found on our number line? We did. We found that there were 23 puppies in the 12th term. So you can see that this matches up quite nicely. So then in this case, again, I can have the kids screen capture their work and then they can drop it in to their slides. It might take a little bit for you to teach the students how to screen capture because everybody's computer is a little bit different, but this is a nice efficient way for them to demonstrate their learning. Eventually, the 100 chart maxes out. We can only get so many terms onto a 100 chart. And developing more into the junior years, maybe around grades 4, 5, or 6, they can start graphing. This is a fixed graph that I put on here that the students can work on. However, I strongly recommend they use this graphing tool because this will make many more connections, especially with respect to changing the scale. I'm going to show you what I mean. So I have opened up this website right here. This is GeoGebra for the graphing calculator. I love this website. Oops. I love this website because I can go into all the quadrants if I need to. But in this case, we are mainly just looking at the positive quadrants on the x-axis and the y-axis. And I have my term numbers down here and my values up here. What I like about this website is I am looking at a scale of 1 right now, but as I zoom out, I can change my scale. So you can see that I'm now changing my scale to 2s, and I can zoom out more and change it more now to 5s and so on. So this is really great for the students to be able to change the scale and to identify what is happening later in their pattern. So you'll see what I mean. In term 1, we had a value of 1 puppy. So I'm going to put that there. Okay. In term 2, we had a value of 3 puppies, I think. Yep, 3. In term 3, we had a value of 5 puppies. And in term 4, we had a value of 7 puppies. And you can see we are increasing by 2 each time. Do you see how this is going up by 2? This is going up by 2. This is going up by 2. So you can predict what would be in term 5. It would be 9 puppies. Now, if you take a look at this and we connect these with a line, oop, there it is. There you go. And I'm just going to go back here. I put an extra dot in that I didn't want to do. Okay. Oh, where'd my line go? Get back here, line. Whoop, boop, 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 boop. And actually, while I'm here, I'm going to come down and make a point down here. Okay. So you can see that I connected these with a line. I'm just going to go back and move this. And so now I can see that this is an increasing linear pattern. It is going up, and I can predict what is going to happen in later terms. So you can see before we were looking at the value at term 12, and we had decided that it was 23 puppies at term 12. Well, let's see if that is indeed the case here. So at term 12, if I were to go up and 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 up, and I like how this tracks up with me at term 12. You can see that I intersect at 23 puppies at term 12. I'm going to put a point right there. At term 12, I have 23 puppies. So you can see that here. If I want to ask now how many puppies would be at term 100 or term 80, let's just go out to 80. You can see how I can change the scale, and at term 80, I would have 160 something puppies. So it's not exact because my scale is so far out, but about 160 or a little bit after that. So you can see how this is efficient to identify where the pattern is going, and I can look into greater values of or greater term numbers at this point and greater values of how many puppies would be in there. So we're becoming more and more efficient. Now, what I brought it back to, I'm going to zoom back in to my scale of ones, is you can see that I marked here at term 0, so along my x-axis, I have a value of -1. Again, pay attention to that. I showed this to you on the number line that we did before at term 0, a value of -1. Now we can see this on our graph that we have -1 where it intersects at the y-axis, at the value. So I just want you to pay attention to that because that will help the students with their understanding of developing the algebraic formula. So once again, I like to have the students show their work. So I'll have them screen capture their work and I will have them drop this image in. And it's important to teach them usual graphing etiquette, labeling, how to plot, giving it titles. I didn't do all of that right now, but dropping it in. Now you can see I made a fixed graph for them here. They can use that. The problem is that they would not be able to interact with it into the negative integers or changing the scale, but it is an option at least, okay? I would much rather see the picture of the digital representation. And then finally, as we get into grade 8, and actually grades before grade 8, up to grades 6 and 7, maybe even grades 4, and under can create a table of values, a T-chart. A T-chart can go vertically or it can go horizontally. In this case, I have it horizontally, so you can change it however you want. But students at most grades can be able to fill in at least our positive terms here. So at term 1, we had 1 puppy. They're just filling in the values. Term 2, we had 3 puppies. At term 3, we had 5 puppies. At term 4, we had 7 puppies. We can predict at term 5 that we would have 9 puppies. And then we put the nth term, we're now substituting our term number for anything that we choose to use. So n is our algebraic expression. Okay, we can substitute that for any term that we are trying to solve. So that is what we're going to. We can see that we are increasing by 2 each time. Now, we can use this data to help us figure out what our algebraic formula is. The hint that I gave to the students is that they need to find out the value at term 0, and we'll find out in a moment why. Let's first look at, we are increasing by 2 each time. So whatever our term number is being multiplied by 2. Repeated addition is the same as multiplication. So we can see that whatever term number we're using, we're just adding 2 every time repeatedly. So we're multiplying by 2. So we can make our formula n, and I'm going to just make that red, n, black again, times 2, because we're repeating by 2 every time, so we're multiplying by 2. However, our formula can't be finished there. Let's substitute a number in for n and see if it works. Let's try term 3, where we have 5 puppies. If I took that n and I put 3 in there instead for the term, if I did 3 times 2, that would give us an answer of 6. But that's not correct. We have 5 puppies. So we have to make an adjustment in order to make this formula work. And that's because at term 0, we didn't start at 0 puppies. Generally, if we started at 0 and we counted by 2s, it would go 0, 2, 4, 6, 8, 10. But we didn't start at 0. We started at a different value in order to get 1 for our first picture representation. So if we are adding 2 every time, it would make sense that we are subtracting 2 to find out this value. So if I had a value of 1, and I subtract, oh, what's going on here? If I had a value of 1, oh, it's not pulling, oh, it's behind the picture, that's why. There we go. If I had a value of 1 and I removed 2, you can see that then I have negative 1. I'm trying to cross that off. There we go. I have negative 1 remaining. So in this case, I'm going to put negative 1. Can you see this on my graph? Negative 1. And on my number line, negative 1. So we can see these connections as we're going through. In the early years, the students don't need to see the negative numbers, but by grade 8, we need to be able to solve that the value at term 0 was negative 1, and then we counted by 2's. So negative 1 plus 2 would be 1, and then continuing from there. So now that we have a negative 1 right here, we need to make that adjustment. So we need to put minus 1. So negative 1 minus 1. Now let's try this formula for term 3. 3 times 2 is 6. Take away 1, it is 5. That is correct. So our formula is n times 2 minus 1. Let's now take a look. We were looking at term 12 through all of our examples, and we had determined that it was 23 puppies in term 12. So let's try substituting n for 12. If we did 12 times 2, that would be 24. Take away 1, it would be 23. Is that correct? Yes, it is. So that is why I take us through all of those representations so that we can see what is happening to make sense of our algebraic formula, building our algebraic formula, and also when we're solving algebraic formulas. So I hope this helps over time. Maybe try now decreasing patterns. Maybe then try building in some math problems with money. Try then building in not an algebraic formula, because that would go into high school, but representing patterns that are not increasing by 2 every time. Maybe it's increasing by 2, then increasing by 3, then increasing by 4, and see how our graph changes and how our 100 chart changes and how our number line changes and so on, because it will help us to understand what is happening with the numbers. So I hope that this helps, and enjoy. Do this often with your class, and I'm sure that it will help to develop a solid understanding when they get into high school. Thank you.